Okay, here's some problems that we will do in class today, some ones that kind of trick people when they get to their accelerated math. So I want to just make sure that we focus on these a little bit, okay? So this first one, notice it has a cube root out of here instead of a square root. So we haven't really done much with this. And so I will just sort of think about this as three separate radicals. And we will think about simplifying each one at a time, okay? So this 108, we're going to prime factor that, and 108 does happen to be an even number, and 108 would be 2 times 54. So I am going to break this down as 2 times 54, which can be broken down into 6 times 9, which can be broken down into 2 times 3, and then the 9 can be broken down into 3 times 3. So here are all of your prime factors here. Okay. And then if you remember the story about the scary neighborhood, the house that's in the scary neighborhood and you can't go out unless you have a buddy, well, here we have a 3. And so since this is a cube root now, you can't leave the house unless you're in groups of 3. So this group of 3 3s can leave the house or go outside the radical, but this group of 2 2s both have to stay inside because they don't have a third person to go out into this neighborhood and get outside the radical. Okay, so we will go ahead and rewrite this now. This group of 3s again can go on the outside, and then I will have to have the cube root of a 2 and a 2, which of course is the cube root of 4. So that's how much that one can simplify. Then when we get to the x term, what happens there is, sorry, this got messed up on me. What happens there we go, is similarly to what we did in the last unit or last lesson. If this is a 3 right here, we were used to seeing it be a 2, but now it's a 3, so I'm going to still follow the same rules and go x to the 7 thirds. I'll rewrite it like that, which of course becomes x to the 2 and 1/3. Okay, this is still your outside exponent. This is still your inside exponent. It's just that now we have a cube root here instead of a square root. But I have an x squared on the outside and I have x to the 1 on the inside. Okay, and then with the y's, we'll sort of follow that same procedure. This will be y to the 13/3, which of course is y to the 4 and 1/3. So here's your outside exponent, here's your inside exponent. So again, I'm dealing with a cube root this time instead of a square root. The outside is a y to the 4th, the inside is a y to the 1. So this is what I have if I think about bringing this down. I have this 3x to the 4th right here, and then I have an x squared cube root x, and I have this y to the 4th that I'm bringing down, cube root y. So I will just go ahead and make that a little bit prettier and combine everything that's on the outside with everything that's on the inside. So on the outside, I have a 3, and I have an x squared, and I have a y to the 4th. And on the inside, I have a 4 and an x and a y. And that is what my problem should look like. Okay, we'll do one more similar to that. This time we're dealing with a 4th root power. Same process, okay, except for now you're looking for groups of 4 when you prime factor it to leave the house. So when I take 512, it's an even number. I will divide it by 2. So 512 is 2 divided, or 512 divided by 2 is 256. That's still even. If I divide that by 2, I get 128. If I divide that by 2, I get 64. And if I divide that by 2, I get 32. We're getting there. And if I divide that by 2, I get 16. And if I divide that by 2, I get 8. If I divide that by 2, I get 4. And those are each divisible by 2. Oh my goodness. Okay. So my prime factors are a whole lot of 2's. Lots of 2's. All right, there's all my prime factors. Because this is a 4 right here, I can't leave the house unless it's in groups of 4. Okay, so I have this group of 4 2's that can leave the house. I have this group of 4 2's that can leave the house. And then I've got this lone one up here that has to stay inside of it. Okay, so when I simplify that 512 piece, what I will have is I have 2 groups of 2's on the outside, and then I have one group of 2's that has 2 that has to stay on the inside. So hopefully you can see that this becomes 4 times the 4th root of 2. Okay, so that's that part. Now let's deal with the x. So if I deal with just the x part, what I'm really doing is I'm taking the 4th root of x to the 9th. So again, I'll think about rewriting that as a fraction instead, as 9/4. This number goes on the top, the index goes on the bottom. Okay, so x to the 9/4 is the same as x to the 2 and 1/4. So here is your outside exponent, and here is your inside exponent. So I have x squared on the outside, and I have x to the 1 on the inside, and this is still a 4th power. All right, and then if we think about the y piece to it, I have y to the 14th, okay, on the inside. So this is really like taking the 4th root of y to the 14th, which if I write that as a mixed number, or as an improper fraction, would be 14/4. And as a mixed number, 4 goes into 14 3 times with 2 left over. So this becomes 3 2/4, which I know does reduce to 1/2, but you don't want to reduce it here. You want to leave it as 2/4. So here's your outside exponent, here's your inside exponent. I have 2 left over. So this would be y to the 3rd power, and then the 4th root of y squared. Okay, and now we'll take this all and we'll put it all together. Anything on the outside, 4x and y cubed will come together. And then of course on the inside, I have the 4th root of 2x y squared. Phew-ta. Okay, and that's what that one would look like. And then we've got one last one, and I want you to think about reducing anything you can first. So a 5/3 unfortunately does not reduce, but this x cubed over x does, and so I can subtract that, and I would have x squared left on the top, but nothing left on the bottom. No x's left on the bottom, I should say. So here's where I'm at right here. You can't leave it like this, because what this really means is the square root of 5x squared over the square root of 3. So when you have a square root of the fraction, it's really the square root of the top over the square root of the bottom, and you can go back and forth between those two forms. However, you can't leave a radical in the denominator. And so now I will need to rationalize the denominator by multiplying by root 3. And so what happens on the top then, when I multiply that out, 5x squared times 3 becomes 15x squared on the top. And on the bottom, root 3 times root 3 is root 9. And the square root of 9 is 3. And now I don't have that in the radical anymore. And then the only thing I can do is try to simplify from here. The square root of 15, if I prime factor that, I would have 3 and 5, but neither of those are perfect squares, so that, and I don't have partners to leave the house with or anything, so I can't do anything there. But I can remember that there's this 2 right here, and I can rewrite that x squared as on the inside as x squared over its index, which becomes x to the 1st on the outside. So this whole thing can simplify as x to the square root of 15 over 3. Okay, and that should be your answer there.